All right, so here's your 4.1 to 4.3 review. So this year, the test is still Thursday. And let's see, for honors, it's going to be on Math Excel. And for regular, like second and fifth and sixth, it's going to be on paper. So you need to know that. And then you also need to know that the 4.3 Math Excel is due Wednesday at 11:59 p.m. Okay, so that's that part of it. Now on here it says the attic truss shown to the right provides open space in the center for storage. In the truss you have your two triangles that are congruent, and it says list your congruent corresponding parts. The first thing I'm going to do is I'm going to color in the triangle, because there are lots of figures in here, but these are the ones we're really interested in. The other thing, just as a reminder, the G corresponds to the M, so you could circle both of those. This is optional, but this is one way to do it. And then with the E and the N, you'd put a square or a rectangle around it, around these two, and then you could do a triangle around this one or leave it blank. So this is one method to do it. You don't have to do it this way. You could just do the numbering system, which is what I actually prefer, but some people are visual. So whatever works for you. This is 1, 2, 3. This is 1, 2, 3. And so FGE would be 3, 1, 2. FGE would be 3, 1, 2. So that means that I've got to do 3, 1, 2 for this one, so that's LMN. So again, you can either do the symbols or you could do the number. The next one is simply 1, 2, 3, and so that's MNL. The third one is 2, 3, 1, so that's NLM. Any questions about those? Okay, then for the sides, this is 1, 2, so that'd be MN. You put it below here. That's an extra long line segment symbol that they did. And for the next one, it's 2, 3, which is NL. And for the last one, it's 3, 1, so that's LM. So remember, this is about using the definition of congruent triangles. And so you have 3 sets of angles that are equal and 3 sets of sides that are equal. Any questions? Okay, I'm just going to move it up to like right there, where you can still see the answers. Okay, on 2, this one has A corresponding to D, so you know it's first to first. So that means you can do x plus 21 equal 2x, or you could say 2x equal x plus 21. What I prefer doing is put the one with the bigger x term on the left. And so I'm going to subtract x like this, and you end up with x equal 21. So that's the way I do it. If you'd rather do it a different way, you can. And then this is going to be 21 plus 21, which is 42, and 2 times 21, which is also 42. That's how you know you did it right. Any questions? Okay, on this one, it's BC, which are the last two, to EF. So again, you set these equal. And I'm going to put 4x plus 2 equal to x plus 17. So then I subtract x. 3x plus 2 equals 17. Then we're going to subtract 2. So we get 3x equal 15. And then divide by 3, so we get x is 5. So then over here, 5 plus 17 is 22. 4 times 5 is 20, plus 2 is also 22. And again, that's how you know you did it right. Any questions? Remember, if you don't like solving equations this way, although that's our goal, if you really wanted to, you could do it this way. Just want to remind you all about it. So you could say x plus 17 for this one, and 4x plus 2 for this one. The problem is only one of the lines showed up, and I know this one has a y-intercept of 17 because it's pretty high up. And so you just got to work with your window a little bit. I'm going to put 30 for this one. So now I see where they cross. Okay. And then you can do menu, analyze is number 6, and then intersection is number 4. So you can type 4 or just scroll to it. And the lower bound means the left side. So there and then there. So what you see is that, and I showed a hand, so I pushed it, and now I can move it over and drop it. So 5 comma 22, so 5 was our x and 22 was our y values. So if you want to do it that way, you can. Just wanted to show both methods. Any questions? Okay. The next one, we've got 42 and 3x, so we have 3x equal 42. So then when you divide, you get 14. And on this one, we got 2t equal 8. And so then you divide by 2, and so you get t is 4. So if you didn't get a whole number answer, then you'd need a decimal instead of a fraction. Make sure y'all pay attention to whatever the directions on the problem are, because sometimes it wants a fraction. Any questions? Okay, the next one we have is number 5. Now on this one, if I just glance at it without paying too much attention, I see sides have numbers, and so I might think that it's going to be side, side, side. And these numbers correspond, but the others don't. You've got 5 and 7 and 4 and 6. So those numbers don't match, and so you cannot conclude that it's congruent, and it's not possible to show angles or sides. So this would have 2 possible answers right there, B and C. So we would need the numbers the same, and then you'd pick all 3 sides congruent. Or if you had angles marked, then all 3 corresponding angles. Okay, so on this one you've got this figure, and you've got a lot of given information. This first one is part of that given information. You've got the HG congruent to KG, and this one. I'd recommend, if it has like a number here, you just choose it. You don't have to write this if you don't want to in the blank. You could just choose this as given. The next one says reflexive, and all of these are reflexive as far as your choices, but in your figure, you know this is going to be the reflexive one. So if you see JG or GJ, that's what we want. And that's going to be the last one. So we've got that answer. Any questions? Okay, then the next one says angle H congruent to angle K, which is part of our given part, and it's marked. So you're going to get given for that. And the next one's talking about the parallel lines, which were also given. So we've got given, then the GJ one, and then given, given. Okay, so there's your first four. The next one is this angle, JGH. So that'd be this angle, JGH, and GJK. GJK is this angle. So think about this as being the two parallel lines cut by your transversal, so alternate interior angles are congruent. And so alternate interior angles of parallel lines are congruent. Alternate interior angles of parallel lines are congruent. So then the third one, they're using the third angles theorem, and all of these are angles. So we've got to pick, looks like this angle that's in red to this angle. So that's the one with J in the middle and with G in the middle. So that's this one. Any questions? Okay, so then you have your triangle congruence statement, and this is when you would normally choose like SSS, SAS, something like that. But because we went through every single side and every single angle equal, then it's going to be definition of congruent triangles. Definition of congruent triangles. So that's what you get for number 6. Any questions? Okay, so then this one, Randall says he can use the information in the figure to prove the triangle's congruent. Is he correct? And explain. So you have some angles marked as equal with a 1 mark and with a 2 mark. You know the A would be equal to C because of the third angles. And as far as sides, these sides are marked, these sides are marked, and BD to DB would be reflexive. So we have to choose an answer choice that's yes with those. So yes, the reflexive property gives those, and since the third angles theorem is AC, then it's B. So 7 is B. Okay. So number 8, this one, just when we're looking at it, it shows WZ and it shows WD. Now, the way this problem works is that WD is in the second statement, so don't use it. So don't use WD for your answer right there. It's asking what WZ is equal to, and really it's all four of them equal to each other. But if we can't use WD because it's right here, then ZD is the one that it's definitely not, and so it's SD. So that's a little bit tricky, but there's logic behind it. You can't choose WD because it's right here. Does that make sense? Okay, and then the next one says WD congruent to, we could use SZ. It's not WD because that'd be reflexive, and it's not ZD, so it's the top one. So at this point we know something about side, another set of sides, and this is the reflexive side, so you're going to choose reflexive. And so because it's all S's over here, then it's going to be SSS. Now notice on this one, this part you don't have to write. No angles are marked, and it's not like an X with vertical angles. So that's how you know it's not going to be something like side angle side or anything with angles. So if you just see a figure like this with only sides marked and then a reflexive side, then you're going to need side, side, side. Does that make sense? Okay, so that was number 8. Number 9, this time we've got parallel lines, and just as a hint, if given parallel lines, it's going to use angles. And usually it's going to be alternate interior. So as we're working through this one, we're not going to have side, side, side. It's going to be side, angle, side. So it's not side, side, side. What we know from the diagram is this is a set of sides, and so is this. And if our choice is SAS, that it must be this angle for SAS. So it's going to be the little angle K. Okay, so that's going to be our approach. Now what we have is a couple of given statements, then we have FK congruent to FK, which is reflexive. Then we don't have anything here. And this is the part where it was confusing to somebody. It says FL congruent to GK, but that'd be if you use SSS. So that's the first thing. But look at the justification under 3. These justifications don't match sides, because this is about angles, this is about angles, it's definitely not given, and this is about angles. So what you know from ruling out choices is it's not going to be this one. Alright, so then we need to look at this K angle, so to speak. So that's as well as this K angle. You've got your two parallel lines cut by your transversal, so those are equal. That would be like LKF equal to GFK from alternate interior. And so let's find that choice. There's the LKF and GFK. Okay, so it's the second one right there. And as I said, alternate interior, so that's this one. One more quick note about this. You can't use these red angles since it's side angle side. Which would be this one to this one. Because that would not be side angle side, that'd be that wouldn't be anything. So based on where those angles are, we couldn't do the problem because the side is too far away. It looks like if you did it that way, you'd have to set both sets of alternate interior angles and do AAS and not use a reflexive side. So that's a little complicated or extra stuff, but it's got to be this second answer because SAS has to be in a row. All right, so now we're done with number 9. Any questions about that? Okay. Number 10, this one we've got angles marked and one set of sides. It wants you to use side angle side. So that'd have to be this one with this one. So that's the only extra information we need. So that'd be the GL congruent to NM. It can't be this one because that also says GT congruent to NQ. So that's why it's not that one. Because if you did this one, then it would be side, side, side instead of side angle side. And we're supposed to use side angle side. Got it? Okay. Then number 11. This one is SSA, and this one's SSA. What we want is SAS, SAS. So because of that, if we've got these two sides marked, then it has to be the W angle for side angle side. And there's your side, so it has to be the R angle, again, for side angle side. So it kind of goes like that. So it's got to be that W congruent to R. W congruent to R is needed because the angles have to be between two pairs of sides because it's SAS. So that's choice B. So don't choose the one that has extra information. Okay, number 12. On this one, we've got one set of sides marked and another set of sides marked, but we don't have third sides. third side's not marked, and also angle Z congruent to D is not marked. And we don't have vertical angles, so the triangles are not congruent. There's not enough information. So if you only have two pieces of information and not the vertical angles, then you just choose that it's not necessarily congruent. Any questions? Okay, 13. Determine whether these triangles are congruent. If so, name the postulate or theorem. So based on the drawing, we've got this angle and we have this shared side, which is reflexive. We also have these two parallel lines cut by this transversal, so these angles would be equal from alternate interior. And so in this case it'd be ASA. So that's D. So again, this last part is from alternate interior. So that's ASA. So remember, it never marks the reflexive side. You just kind of need to know that. It also never marks the vertical angles. You just need to recognize vertical angles. Alright, so our next one, this shows two triangles. These are light marks. So it's not on the test unless it's electronic, which would be honors in this case. What you can barely tell is that N corresponds to R and M corresponds to Q, because both of those have 2 marks. You can kind of barely tell that. And then the third ones aren't marked, but you know third angles are equal. So because of this, it would be ASA, because you can see the sides marked. So that'd be this one. Any questions? All right. Now on this one, we've got N congruent to P, which is already marked, MO congruent to QO, so that means this. The triangles we're interested in are the MON triangle with the QOP triangle. So what we know is these sides are equal, and we already know the vertical angles are equal. So if you look over here, MON congruent to QOP, that's because of vertical angles equal. Okay, and then for number 4, the triangles would then be congruent from, let's see, this angle is already marked, and we know this angle. It's SAA, which is the same as AAS. So that's that one. Any questions? All right. Number 16. Given angle 1 congruent to 2 and DH bisects BDF. So there's the bisect statement which is given, and then it's talking about these angles. So if this was the bisector, then these angles would be equal, which is what they're talking about, BDH and FDH. So if those angles are equal, you've got an angle. You've got the reflexive side, and you've got an angle here. So this is going to be ASA from the figure. Alright, so remember what we do is we look at this word, and if that's the reason that it gave, this would be definition of bisector. Because bisector and bisects are alike. On number 2, that's the reflexive, because this side is in both triangles, and then it's ASA. Now, don't make this mistake, because proofs can be in any order. Proof statements can be in any order. Just because this is AAS doesn't mean that it's AAS theorem. Okay, so basically on this, use the figure, and we know it's not SSS or SAS, and based on the figure, it's got to be ASA. So just because these statements are like AAS doesn't mean that it's right. Use the figure to tell if ASA or AAS. So that's why I usually don't even mark anything over here, but I know somebody missed something before because of that, so that's why I wanted to mention it. Okay, so for number 17, we've got these parallel sides, which was given, so we've got these angles, BAC congruent to DCA. That would be alternate interior, so I'm choosing that one. And then you got more parallel lines with the other angles, so again you're going to have alternate interior. So 2 straight or alternate interior. That's the ACB, which is this angle, congruent to CAD, which is this angle. So we've got 2 that are alternate interior. Then you've got, this is the same thing, so we've said several times that'd be reflexive. It's not symmetric, it's reflexive. So let's see, we've got an angle, we've got another angle, and we've got a side. So use the figure. It's either ASA or AAS. So we can rule out a couple of choices. And based on the figure, it's ASA, because it's the side that's reflexive between 2 angles. So that's ASA. Got it? Okay. All right. Now this one's worded a bit different. It says 2 non-congruent triangles. So that means ones that are not the same size. So that means it's not C. two triangles that are not the same size that do have two pairs of angles that are equal and one set of sides that are equal. So these two angles are equal, and this side is equal to these two angles and this side. So in other words, a side is marked and it's not a congruent triangle, so it has to be in different positions. In different positions. And so that means it's going to be A. Because on B, no sides are marked. Any questions? Okay. Then this one, name two triangles that are congruent by ASA. So here's this one that is ASA. This one, hold on, let me see something real quick. Okay, so if we go X, Y, Z, which is what the order was, it's like unmarked, and then one mark, and then two marks. So on this one, the unmarked would be A, the one mark would be B, and the other one would be C. ASA. Oh, you know why this is wrong? Because on the side, this side AC has two marks, and this side has one mark. So the side BC has two marks. So it's not correct. So it's not that one. So even though you could see this is ASA and ASA here, that BC part has two side marks and this only has one. Alright, so this is kind of tricky a little bit. And then on this one, if we've got angle, side, angle, this side has one mark like this one, and so that's what we were going to want. The unmarked is D, the one or single mark is E, and then the last one is F. So X, Y, Z to D, E, F. Okay, so now we're finished with the review. Now you can work on your Math Excel. And if you need an extra copy of the review, let me know.